Welcome to Homework Lib.
So here we have the two blocks being connected with the string, which is having the mass of 4 kg and a force here as shown in the diagram here. 200 Newton is applied, and first we need to draw the free body diagrams for all these three objects. So if we see this object having mass 5 kg, here there is applied force of 200 newtons. There will be tension here, and there will be the weight, and this weight will be its mass times acceleration due to gravity. So taking g as 10, weight will be 50 newtons. Talking about the free body diagram for this 4 kg string, there will be tensions at the two ends, and here there will be its weight also that will be in the downward direction. So the weight will be also equal to mg, so we do not need to determine that, just we need to show all the forces. And if we talk about the 7 kg object, this also has the weight in the downward direction. This has the tension in the upward direction. Now here we need to determine the acceleration of the system. So to get the acceleration, we use Newton's second law. That's the net force. We divide it by the mass of the system. So the net force is 200 and the total mass is 5 plus 4 plus 7. So that becomes 200 by 16. So if we simplify this, we get the acceleration as 12.5 meters per second square. So this gives us the acceleration as 12.5 meters per second square. And now we need to figure out the tension at the topmost point of the heavy rope. So at the topmost point, if we want to figure out the tension, so we will see the free body diagram of this 5 kg object. So there is the weight, that's 50 newtons. There is tension also in the downward direction, and there is applied force of 200 newtons. And because of this applied force, this block moves up with the acceleration which we have computed here. So we use again Newton's second law. So net force is mass times acceleration. So its mass is 5 kg. So net force, as it's moving in the upward direction, so upward force will be greater than all the downward forces. So we get the equation here. Putting the value of E as 12.5, what we have obtained, we get 200 minus 50 minus T equals to 5 times 12.5. So on solving this here, we get the T here as 87.5 newtons. So T comes out to be 87.5 newtons. And this is the tension at the topmost point of the string. And we need to even figure out the tension at the midpoint of the rope. So this was 5 kg, and we will now consider this rope made of two parts. As this rope was having a mass of 4 kg, so this is 2 kg and this is 2 kg, and there is a block of 7 kg mass. So we need to figure out the tension at the midpoint. That means we will consider this as a system now. So now the mass becomes 7 kg. There is tension here. There will be weight, that will be 70 newtons. And there is of course the force, which is 200 newtons. And it moves with acceleration 12.5 meters per second square. So we again apply Newton's second law. So 200 minus T minus 70 equals to 7 times 12.5. So here once again, if we solve this, we're gonna get here P as 42.5 newtons. So this is the tension at the midpoint of this heavy rope.